Okay, hi everyone. This is the first video I'm recording for this, so hopefully everything turns out well. I'm going to be starting on our next topic, which is going to be on fields. We've got three kinds of fields we're going to be looking at. We've got gravitational fields, which is our first topic. Then we're going to be doing, I think it's electric fields and magnetic fields. But a couple of lessons on gravitational fields before we move on to the other types. So first thing we're looking at is what we call Newton's law of gravitation. Now I'm using the swivel for this, and it makes the video kind of, I'm new to this, who knows if it'll work or not, but we will see and hope for the best. The video is currently reversed on the iPad, so hopefully I can switch that, mirror image it with some editing magic, but whatever. So when we're talking about gravity, we're talking about gravitational fields, and we're talking about Newton's law of gravitation. Hopefully this will switch to, there we go. So we're talking about this equation here, which says that the gravitational force acting between two objects is equal to these things multiplied and divided by each other. We've got a few different bits. We've got two masses, mass 1 and mass 2. Doesn't matter which one we say is mass 1 and mass 2, just two objects. There's going to be some gravitational force between them by virtue of the fact that they have mass. So anything with mass is going to produce a gravitational field. Any two objects with mass are going to interact with each other via some kind of gravitational force. Now, sometimes our gravitational force is going to be very strong, like the case where you've got the Earth, which is very big, producing a gravitational field that interacts with everything on its surface. But any two objects, I take these markers, for example, conveniently located, they have mass, they're going to produce their own gravitational fields. They're going to be very weak just because these markers have very small mass. There would be some very, very weak gravitational force acting between them, but since they're so small in terms of the mass, that gravitational force turns out to be negligible between these two objects. So gravitational forces are just forces between objects with mass. We've got, I might skip to this bit, a big letter G. It's the gravitational constant. It's a number that is switchy, chirpy. It's got a value of 6.67 times 10 to the negative 11 Newton meters squared per kilogram squared, but the units aren't that important. What matters are the value. You just use that number for your G value when you do an equation like this. And the other part is the R squared value down the bottom. So it's not just the distance between two objects, but the distance between their centers. And that's going to become more significant when I go through an example of it in a moment. So now for some magic. Okay, so if I had an example about calculating the gravitational force between the Earth and someone standing on the Earth's surface, I'd find that using this equation here. Let's see if I can move this up, make it look better. Who knows, hopefully the glare doesn't completely ruin this. Anyway, so I must find the gravitational force on the person exerted by the Earth. Now, for that example, the person has a mass of 60 kilograms. The mass of the Earth is just a standard number. It's 6 times 10 to the 24 kilograms. So I've got my value of gravitational constant. I've got the mass of the Earth. And I've got the mass of the person. Down the bottom, I've also got a value of 6.4 times 10 to the 6. And where I got that number from is that's just the radius of the Earth. Because like I was saying before, someone standing on the Earth's surface, you might be tempted to think that the distance between the person and the Earth is just going to be, well, 0, because they're on the Earth's surface. But because the definition is between the centers of the two objects, it's the distance that we're talking about, the R value, is going to be the distance between the person and the Earth's center. Because the Earth has a radius of 6.4 times 10 to the 6 meters, that's going to be the value that we use for the R in our equation down there. So we stick that value in. We've got our G, our two masses, our radius, well, it gets called radius, but it's just the distance between the two centers. We make sure we square that bottom bit, and then if we do that, we're going to get out an answer of 586.2 newtons. Now, that's a long way of doing that. If I'd been quick and short and smart about this, I could have found the exact same answer by just saying that Fg, the weight force on the person, the force of the gravity upon that person, is going to be mg. It's going to be their mass, which is 60 times 9.8. Without even having to use a calculator, I know that that's going to equal 586.2 newtons. So this equation it's applicable to any two objects with mass, but when you've got the force between the Earth and some object on the Earth's surface, it's just as quick and easy to just say that the force is going to be mg, and we know the value of g on the Earth's surface, it's 9.8, so we can use that to do our calculation a bit more quickly without having to worry about all the different components of this equation. So just when you're using this equation, you want to make sure that you're using brackets carefully. I've put these in brackets, and when you put that into a calculator, you want to make sure those brackets go in, because you're dividing by something that's being squared and there's a multiplication in the middle. So just when you're doing a calculation with these numbers, make sure you're making liberal use of brackets to make sure that BODMAS doesn't kind of screw you over and make it get calculated in a way that you don't really want it to. So this is just how you do a calculation using Newton's law of gravitation, just with two masses. Doesn't matter which one's mass 1 and mass 2 again. I'm kind of rambling at this point because I should probably just end the video. There will be a second part to this where I talk about other stuff, but I just wanted to see whether this worked before I tried other things. So cool.